Taniya M U presenting before you the seminar of electricity chapter. The topics I have taken is resistance and Ohm's law. Let us know the history of resistance. In January of 1781, Henry Cavendish experimented to measure the current. He wrote that current is directly proportional to the degree of electrification. But this was unknown till Maxwell published it in 1789. But for their bad luck, the credits does not go to them. George Ohm worked on the resistance in the years of 1825 and 1826. He published his results in the book named The Galvanish Kettle. He performed experiment using different circuit setups such as varying conductors, ammeter, voltmeter, cell, etc. Let's take a simple circuit with components such as ammeter, voltmeter, bulb and a battery. Let's perform an experiment by varying the potential difference and note our readings in the ammeter. For providing the potential difference of 12 volts, we obtained a current of 3 amperes. And for the potential difference of 9 volts, we obtained a current of 2.25 amperes. And for the potential difference of 6 volts, we obtained a current of 1.5 amperes. Now, let's plot these values on a graph. What do you observe? Yes, it's a graph we have obtained and it's a straight line. And this tells us that V is directly proportional to I. That is, voltage is directly proportional to current. We can write it as V is directly proportional to current. Now, to remove this proportionality symbol, we must multiply current with a constant. And this constant is nothing but resistance. So, we can write it as V is equal to R into I. This is nothing but an expression for Ohm's law. Ohm's law states that the voltage across a resistor is directly proportional to the current flowing through the resistance. Now, what is this resistance? It's an intrinsic property of every conductor that depends upon various factors. Now, let's look upon the factors. Number 1. Material. What kind of material is that conductor made of? Next one, the physical dimension, the length or the area. As the length of the conductor increases, the resistance also increases. This tells us that resistance is directly proportional to length. And area. As the area of the conductor increases, the resistance decreases. This tells us that resistance is inversely proportional to area of the conductor. Next is its internal structure, that is its atomic structure of the conductor. Next, its temperature. Now, how can we vary the resistance? Yes, we can vary the resistance by varying all these factors. We use a circuit element called resistor, as you can see in the figure, that resists the flow of current. Now we can replace the bulb which we have used in the previous experiment with the resistor. Now I can ask you, what is a bulb? Yes, you can say it. The bulb is a special kind of resistor that heats up and emits light when current is flowed through it. Now, from the Ohm's law, we have derived that V is equal to R into I. That is, voltage is equal to resistance into current. Now, let's replace one of the reading we have got from the experiment in this expression. We have got that for the potential difference of 12 volts, we have received a current of 3 amperes. Let's replace it. So, 12 volts is equal to 3 amperes into resistance. So 12 volts by 3 ampere is equal to resistance and 4 volt per ampere is equal to resistance. it says is that for the potential difference of 12 volts and for the current of 3 amperes, we can obtain a resistance of 4 volt per ampere. Now, what is the SI unit of resistance? The SI unit of resistance is ohm, which is denoted by the symbol omega. Now, how can you define 1 ohm of resistance? Yes, we can define it as resistance of a conductor that permits 1 ampere of current for 1 volt of potential difference across it is said to be 1 ohm. Now, how can we classify the conductors based on their resistance? We can classify them as good conductors and the bad conductors. The materials which offer free path for the flow of electrons are said to be good conductors. Example, most of the metals are good conductors of electricity. Now, bad conductors. The materials which do not provide an easy path for the flow of electrons are said to be bad conductors of electricity. Example, most of the non-metals are bad conductors of electricity. By this, we can conclude that the metals have lower resistance and the non-metals have higher resistance. We all know that air is a poor conductor of electricity. Wait, we must know this, that air is a bad conductor until to an extent where there is a high voltage across clouds and earth. They conduct electricity in the form of lightning. Now, let's solve the question. The question given is, a hot plate of electric oven connected to a 220 volt line has two resistance coils A and B, each of 24 ohms, which may be used separately in the series or in parallel. What are the current in the three cases? So, what they have given? They have given us the potential difference of 220 volts and the two resistance coils A and B, and they have the resistance of 24 ohms each. And what they have asked? And they have asked the current in the three cases. Case number 1, when the resistors are connected separately. And number 2, when they are connected in series. And number 3, we must calculate the current when they are connected in parallel. Let's solve this. Let's write down the given information. So, the potential difference given is 220 volts and the resistance of each coil given is 24 ohms. Now, case number 1. What is the current when the coils are connected separately? From Ohm's law, we derived that V is equal to IR. So, to calculate the current, V by R is equal to I. Let's replace the given values. So, 220 volts by 24 ohms is equal to 9.2 amperes. So, we get that for the potential difference or the voltage of 220 volts, we get, and for the resistance of 24 ohms, we get a current of 9.2 amperes. And now, case number 2. When the coils are connected in series, what will be their current? And again, from the Ohm's law, we derived that V is equal to IR, and to calculate the current, V by R. And first, we must know the resistance. And we know that when the coils are connected in series, the total resistance will be sum of their individual resistance. So, we get 24 into 2, that is 48 ohms. Now, let's replace in the equation, that is the expression. V by R is equal to I. So, we get 220 volts by 48 ohms is equal to 4.6 amperes. So, we can say that for the potential difference or for the voltage of 220 volts and for the resistance of 48 ohms, we obtain a current of 4.6 ampere. And next, case number 3. When the coils are connected in parallel, what will be their current? So, we get the total resistance. First we have to calculate the total resistance. So the total resistance will be the resistance divided by 2. So 24 divided by 2, we get 12 ohms. And now we can calculate the current. That is, again from Ohm's law, V by R is equal to I. That is, for the potential difference of 220 volts and for the resistance of 12 ohms, we obtain a current of 8.3 amperes. So let's conclude this. What we have obtained? In case number 1, when the coils are connected separately, we obtain a current of 9.2 amperes. And case number 2, when they are connected in series, we obtain a current of 4.6 amperes. And case number 3, when they are connected in parallel, we obtain a current of 8.3 amperes. So, I am winding up my session and thank you.